Hello and welcome to the first lecture of rules of replacement. Now, before we start with rules of replacement and the theory behind it, let us first try to differentiate it with the rules of inference which we have studied. If you remember, I said that rules of inferences, if you remember, were valid argument forms, right? So they were valid argument forms and we studied these valid argument forms, the 9 valid argument forms which are there in our book. Now, these rules of inferences are a little bit different than the rules of replacement which we will be discussing. Now, if you remember again, and allow me to remind you a few things, that here, if you remember, like suppose if we take P implies Q, P therefore Q, this was like modus ponens. So you know that from Q you cannot go to these steps, right? So this direction was not possible. That means from conclusion you cannot go to the premises. However, from premises you can definitely come to the conclusion. This was the understanding. So what it means is that a valid argument form is unilateral by nature, something which we also discussed. Now, when we talk about rules of replacement, which are also used in proofs, and which is a very strong requirement for any natural deduction method. So what we do is that we say that rules of replacements are basically equivalences, right? So rules of replacements are basically equivalences. That means that the LHS will be equivalent to the RHS. The left hand side will be equivalent to the right hand side. So the movement from here to here as well as from here to here, both are acceptable and permissible, right? So this is the first thing which you should understand. So these are basically material equivalences and the left hand side is equivalent to right hand side. So if you have got the left hand side, you can replace it with the right hand side. If you get the right hand side, you can replace it with the left hand side. So this is the most important thing which you should remember. Now, let us see the list of rules of replacement which are provided in our book. There can be different books, there can be different authors, and they may not agree with the same kind of lists. There are sometimes a few rules which will not be given in one book but will be given in some other book. So as I told you right from the very beginning of this course, that we need to follow one convention, and the convention which we are following is the convention of I.M. Copy, which is also a very celebrated book of logic, and we will be using the symbolic logic book initially, right? So here you will find a lot of rules. So let us start with the first rule. Let us take commutation. Commutation, which in short form they write it as com. You can write it as COMM as well. It says that if we have P dot Q, we can replace it with Q dot P. And if we have P wedge Q, so we can write it as Q wedge P. So you can see that the dot or the conjunction is a commutative function, as well as the disjunction is also a commutative function. So you can replace, so you replace the P with Q and Q with P in both these cases. Next, if we take, let us take association. So for association, you can write the short form as ASSOC. It says that if it is P dot Q dot R, Q dot R. So you see the position of the bracket will change here. We can write it as P dot Q dot R. So if we have the same symbols, if we have the same commutation, same conjunction in here, because here also there is a conjunction, here also there is a conjunction, so you can change the position of the bracket. So here the bracket was between Q and R, here the bracket is between P and Q. Okay, the same goes for wedge. P wedge Q wedge R is also equivalent to P wedge Q wedge R. So this is also following the rule of association. Association simply says that if we have the same functions, This will not be true if we have a dot and a wedge. But if we have dot and dot, so you can change the position of the bracket. So if you have a wedge and a wedge, also you can change the bracket. As you can see that we have changed the brackets and the value of it will remain the same. Now suppose, suppose if we have a dot and a wedge function, so how it will work? Let us see. The concerned rule for that one is called as distribution. Okay. So what is distribution? Distribution will have a dot and a wedge function. Like suppose we call it as distribution. Short form is dist. Okay. So if we have P dot Q wedge R, fine. So we write it as P dot Q wedge P dot R. So this is the equivalent function, right? So you cannot change the bracket as P dot Q wedge R, not like that. This P dot Q will be in one bracket, then this P dot R will be in another bracket. The same goes for wedge function as well. If we write P wedge Q dot R, suppose if we have this one, so this will be equivalent to P wedge Q dot P wedge R. So this is the rule of distribution. So till now we have discussed 3 rules. We have exactly 10 rules in the rules of replacement. Now let us take another one. This is also something which most of you know. This is called as De Morgan's law. De Morgan's law. De Morgan's law, short form is D small e m. So we write it as DEM. It says that if you have negation of P dot Q, then it is equivalent to negation of P wedge negation of Q. Similarly, if you have negation of P wedge Q, so it is equivalent to negation of P dot negation of Q. So you know that whenever we operate the negation inside the bracket, the conjunction is changed into disjunction and the disjunction is changed into conjunction. More or less these rules are known to you because you must have studied a little bit of discrete mathematics, or you must have read a little bit of set theory, or some functions and connectives and some these circuits and all. So because of this, mostly students know about the rules which we talked about. Now let us take more rules. What are the other rules in this in our book? Let us first talk about something called material implication. Material implication, short form will be MI. What material implication says? Material implication says that if you have P implies Q, it is equivalent to negation of P wedge Q. Fine. So this is the basically rule of material implication. Similarly, if you have P wedge Q, it is equivalent to negation of P implies Q. So both of these are material implications, and both of them you can use. So for this you can write as this, and for this you can write as this, for this you can write this, for this you can write this. So there is no problem with this, and this is the rule of material implication which we will be also using in the rules of replacement, or from now onwards the proofs which we will be coming. So we will be using all these rules to solve the question or to make a proof of those arguments which will be given to us to prove. Okay, now let us talk about transposition. Transposition. Transposition, the short form is trans. If you have P implies Q, it is equivalent to negation of Q implies negation of P. So you see that in case of implication, it is not following the rule of commutation, right? So P implies Q is not equivalent to Q implies P. Rather, P implies Q is equivalent to negation of Q implies negation of P. So this is also something which you should remember, or which you should understand, that commutation is a rule which is followed by conjunction and disjunction. However, in case of implication, it is transposition. So what transposition says, that whenever you will like to change the position of the atoms, if I call these as atoms, so if you want to change the position of atoms or these simple positions, so you will be developing a negation in them. Okay, so now let us take more rules. Let us start with another simple one. A simple rule is that of double negation. Okay, so double negation, this is also very easy for us to understand. The short form is DN. Double negation says that if we have negation of P, it is equivalent to P. So you know that both the negations have I will say equated them, and see, the two negations can be removed and you will get a simple proposition. Okay, so this is also one of the rules which we will be using, and this is also something which we can understand. Okay, let us take another rule. What can be the another rule? Now the next rule is called as tautology. What is tautology? Tautology, the short form for this is taut. Okay, what it says, that if you have P and P, that means P dot P, this is equivalent to P. If you have P wedge P, it is also equivalent to P. So if you have two atoms and there is, the two atoms are identical atoms, because here also it is P, here also it is P, and they are bounded by conjunction, or if they are bounded by disjunction, so you can just put one of them, right? So this is the rule of tautology, and I may say a few words here. Whenever from now onwards, if you are asked what is a tautology, right? So you have studied tautology as an a priori proposition which is always true. And sometimes we also get confused that any statement which is always true, like the sun rises in the east, is going to be a tautology, but it is not, right? The sun rises in the east is a contingent proposition. It is an a posteriori proposition. However, it is true. There is no question about the truth of that statement, but still it is not a I will say a priori proposition. However, a tautology like P wedge negation of P is an a priori proposition which is always true. So we say that tautologies are a priori propositions which are always true. Now somebody can ask you, what are the other meanings of tautology? So you can always say that a tautology is not only an a priori proposition which is always true. However, tautology is also a rule of replacement, like we are writing over here, which says that P dot P is equivalent to P, or P wedge P is also equivalent to P, right? And for P, you can write both the things. You can write it like here and you can write it like here, right? So for P, you can write P dot P as well, because if you need in some question that for proving you need two P's for some kind of application, so you can write it as a dot function, or you can write it as a wedge function. So as and when you study something and you get some more information, so you need to accommodate that information in your database. So from now onwards, if we ask you, like if there is a question in your question paper next time, and you are asked that explain the meaning of tautology, or explain the meanings of tautology, maybe you will even not see that I wrote meanings, or the question the examiner has asked that what are the meanings of tautology. So you just explain that it is an a priori proposition which is always true, so you will get half marks. If you say that it is also a rule of replacement, and the the value of it is like this, or the expression of it is like P dot P is equivalent to P, or P wedge P is equivalent to P. So in that case, you will get full marks. So these are certain things which you should remember. Let us come to another rule. In fact, there are, I guess so, only two rules which are left. The first one is called as exportation. Exportation, the short form for it is EXP, and this is a very important rule of replacement which we will be using. It says that P dot Q implies R is equivalent to P implies Q implies R. Okay, so why it is an important, I will say, rule of replacement, something which we need to remember, because it changes the conjunction with an implication. So some questions may require you to change or to shift from the understanding of conjunction to an implication, or sometimes you may require to change from implication to conjunction. So this rule will be very, very handy for you. So this is also something which you should remember, that we can change conjunctions to implication with the help of exportation. If suppose we get a question which is having more or less of this form, so you can change it like this. So P dot Q implies R will be equivalent to P implies Q implies R. Now the next rule which we will be talking about is that of material equivalence. Material equivalence, the short form is ME. What does it say? We know that P triple bar Q. This P triple bar Q is also equivalent to Q triple bar P. Okay, but we do not consider it to be any rule. However, to tell you, if there is something like P triple bar Q, you can always write it as Q triple bar P. In fact, you can also see that it also follows the rule of commutation. But usually there will be no need like this. For P triple bar Q, whatever you will be applying, it will be applicable over here as well. So does not matter. P triple bar Q is equivalent to, so if I put a bracket over here, so this is equivalent to P implies Q and Q implies P. In fact, when we were defining the material equivalence, right? So when we were defining the material equivalence, we also said that P equivalent Q, or P materially equivalent to Q, means that it is both the necessary as well as the sufficient condition. So you can see that the conditions of necessity and the conditions of sufficiency both are taken into consideration. There is another rule for P triple bar Q, that is equivalent to P dot Q wedge negation of P dot negation of Q. So if you get an expression like this, and if I am not wrong, I may have to check this one. Yes, I am right. So P triple bar Q is equivalent to P dot Q wedge negation of P dot negation of Q. So this is another expression for it. So as you have seen that we have now discussed 10 rules. These 10 rules are called as the rules of replacements, and some of them are having more than one expression, right? Like tautology is having two expressions. This is also having two expressions. Commutation, association, and so many more are having two expressions. So you can use any one of them depending upon the requirement. In the right hand side, when you will be requiring the justification, whenever we are writing a proof, so we also write a justification for it. So that justification will be whatever the rule is. So if a rule is having, because if you remember the rules of inference, so there is exactly one expression for every I will say rule of replacement, rule of inference. But when we were talking, or when we were discussing rules of replacement, so you can see that there are more than one expressions as well for some of them. So in any of the ways, whichever rule you are using, even if you are using this one or you are using this one, for both of them you will be writing material equivalence. So this was all from my side regarding the rule of replacement, the 10 rules which we have discussed. When we will come in the next lecture, we will be solving some very simple questions. Then we will take the moderate type of questions. Then we will take the difficult type of questions. Okay, thank you.